Hello, welcome back to the channel. I'm Alan, and today we're going to get started on fractions. But before we do anything, we have to know what a fraction is. A fraction is a part of a whole, a part or a piece. So, for example, if you, let's say, have this circle, and you cut it into four pieces. Here, let me make it a little better. Four pieces. This is a fraction. This is a fraction. Like a fraction is basically a part of a whole. So, for example, this would be a fraction if we highlighted this part. One piece is highlighted out of four possible pieces. So we want to know how to write a fraction. If we want to write a fraction, we would write the numerator, which, wait, no, here. First explain this. A numerator, which is the amount, the number of highlighted areas over the denominator. The denominator is the amount of total possible options. So, as we can see, we have one highlighted area and four possible areas. So this would be equal to 1/4. Now, if we go more complex, we can like cut this into 8 pieces. You could see 2 pieces. I'm just saying I haven't changed a thing. 2 pieces out of 1, 2, 3, 4, 5, 6, 7, 8 possible areas. So that would be 2 out of 8, which means 1 out of 4 must be equal to 2 out of 8. And yes, that would be true. Here, let me get that color. This would be true, as based on our pi, we are not changing the amount we have scribbled or highlighted. Now, let's get to operations with fractions. Let's start off with a fraction that has the same denominator on both sides. 1/3 plus 2/3. If we grab our pi again, get our 1/3. Here, let's make 3 equal slices. Yeah, probably shouldn't have that. Here we go. 3 equal slices. Let's start off. Yeah, that's not equal at all. Best attempt. So let's start off with the green. Let's grab our green. 1 out of 3 possible areas. So we would highlight one of them. And the orange over here, 2/3, 2 out of 3 possible areas. So we would highlight these two. And you can see this would be equal to 3 highlighted areas. 3 highlighted areas out of 3 possible areas. So if we had changed this, this is equal to 3 divided by 3. This line down here is just a fancy way of saying this division sign right here. So anything divided by itself, except 0, is equal to 1. So that means 3 out of 3, 3 over 3, must be equal to 1. Now, let's get to subtraction. Or, how about this? Let's get addition to a fraction with 2 different denominators. So let's get 5, let's see, 5/6 plus 3/4. How about that? So as you can see, we can't use the same pi, as these two are 2 different things, and we can't just highlight over them. So let's get our pi out. We cannot just do 6 pieces and then 4 pieces, as that would not overlap and we cannot add correctly. So we need these to be the same thing, like in our previous example. So how do we do that? Well, if we go over to 5/6, we could see 5/6 and 3/4 have a possible way of getting a common denominator, and that would be 12. But you're like, hey, if we just change 3/4 into 3/12, this would not be the same thing. Oops, yeah, let me undo that. This would not be the same thing anymore. And you would be right. We would have to do something to the numerator too to make that possible. So an algebraic way of doing this, if we take 3/4, if we multiply anything by 1, it would stay as 3/4. So, and as previous examples, anything divided by itself is also equal to 1. So we can use that to our advantage. So if we take 3/4, and we need to make these both a common. So what can we multiply by 6 to get something, and that to something to make these both the same denominator? Well, 12 can work. 6 times 2 can be 12, and 4 times 3 can be 12. But we can't just willy-nilly multiply these two together. We cannot just willy-nilly multiply these two together as that. Then this will not be equal anymore. So we need to do something to the top to make it equal. Well, if we do 3 over 3, this would be equal to 1. And down here, as you can see, nothing would change. So we would multiply 3/4 by 3 over 3, and this by 2 over 2. As you can see, we're not changing anything. As if we do 2 divided by 2, this is equal to 1. But what we're doing is we're changing what this looks like. So then we can put it back into our pi. So 2 times 5 is 10. 10. 2 times 6 is 12. 12. 3 times 3 is 9. And 4 times 3 is 12. As you can see, we have not altered the amount. And if you want an example of that, here, I'm going to quickly pause to draw this division. Okay, so what I've done is basically I've taken this 5/6 and I put 6 equal sections in here and wrote them all in purple. As you can see, 1. And let me get a white so then you can compare and contrast. There's 1 right here, another one right here, another one right here, and another one right here. So that's 5 out of 6 possible areas, as you can see with the purple lines. But if we take the both purple and white lines, then there will be 12 equal areas, which is what we've written over here, 10 over 12. And if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you can see they all occupy this one space right here. They all occupy that equally, which means they must be equal. And if we add 9/12, same thing. We would do the same thing with the 3/4, but I just a little too lazy to write all 12 squares again, sections. So if we go back up here, we can see 10 over 12 is equal to 5 over 6, and 9 over 12 is equal to 3 over 4. So now let's get adding. So if we add 10 sections plus 9 sections, here, let's put that back into a white. Why not maybe a red? No, that's not red. This would be equal to 10 plus 9 is 19. 19 sections over 12. Do that in white. 12 possible areas. And you might be saying, well, there can't be more pieces than there are down here. But then this would be called an improper fraction. There's a reason why it's called an improper fraction, as you are improperly placing something up here bigger than the one down here. As then you would be overflowing the pi. But that's fine, as you can actually compute this into a mixed number, or you could keep it like this. So if we wanted this like a mixed number, we would first of all try to draw this in a pi. So let's draw that in a pi. Let me get a bigger eraser. There we go. So let's try to draw a pi for this. So if we get a white, no, that's not white. Here we go. If we get this white again, and we get 19 over 12, we would have to draw 12 equal sections, which would be this. I'm doing the best I can here. This is a little bit of time I have. But hopefully 12 sections. So we would have to draw 19 of them. But as you can see, if we draw 19, we would be highlighting all this. But then we would have, if you counted, 7 remaining. And that's where the mixed number comes in. Basically, you have 1 as you have 12 divided by 12. So you would get, let's see. We would get 1, and then we would have 7 remaining. So then 7, and that would be 7 over 12. That would be the remainder. So we would get this mixed number. So that means this is equal to 19 over 12. And if we wanted to compute this mixed number back, all we would do is turn this 1 into 12. This is exactly the same thing as 1 plus 7 over 12. We want to turn this into an equal denominator, so we would multiply it by 12 over 12 to have it as the same denominator. So then it would be 12 over 12 plus 7 over 12, which would be 19 over 12, which is perfect for what we need. Or we can keep it like this. So what we have here is 5 over 6 plus 3 over 4 equals 19 over 12. If we had something like 20 over 12, we could simplify this. We could divide both the numerator and denominator by 2, and we would get 10 over 6. And then do that again. And then we would get 5. We would get 5 over 3. So then 20 over 12 is equal to 5 over 3. But we don't have that. We have 5 over 6 plus 3 over 4, which is equal to 19 over 12, or 1 and 7/12. Let's get to subtracting. Subtracting is the same thing. All you do, let's say we have 5/7 minus, let's go to green, 3, let's do 3/7. As we already know different denominators, we would do the same thing, multiplying it out. What we do, we have 5 sections, we would subtract them by 3 sections of them, which would get 2 over 7 whole. That would be that. Subtracting is basically the same thing. Now let's get to the multiplying. Multiplying is very simple. Multiplying, if you have maybe 4, let's get a 4. 4 over 9 multiplied by 11 over 2. All we have to do is multiply top by top and bottom by bottom. That's it. That's really it. So then that would be 44 over 18. We could simplify this if we divide both sides by 2. Then we would get 22 over 9. And I do not believe we could simplify this any further. So then this would be our answer. If we wanted this as a whole number, we would count how many times 9 could go into 22. As if you did this, you would be doing 22 divided by 9. And if we tried to do the division, if we get 22 and 9, we would get 2, and that would be 18, 4. And you see 4's remainder, so we would get 2, and then 4 over 9, as that's the remainder of it, and that would be the same thing as this. Now let's get to division. Division, what we would do, so if we get, how about this? 5/3 divided by 2 over 9. This would be called a complex fraction. A complex fraction is a fraction that has a fraction in the numerator, denominator, or both, all in one fraction. So what we would do, we want to get this fraction down here out. So we want to turn this into 1. How would we turn this into 1? Well, we could multiply it by its reciprocal. A reciprocal is basically the numerator and denominator switch. So we would multiply by 9 over 2. As if we multiply this, we would get 18 over 18, which would be 1. So we get this denominator to 1. But anything we multiply in the bottom, we must multiply in the top, as then it would be equal. So now this would be equal to 1. Oops. Here we go. This would be equal to 1. And then all we get is 5 over 3 times 9 over 2 over 1. And anything over 1 is the same thing, so we don't need to write that. So we get, basically when we get 5/3 divided by 2 over 9, we get 5/3 times 9 over 2. This would be the concept called keep, change, flip. What we would do, we would 5 over 3 divided by, this is just the replacement of this, 2 over 9. As you can see, we kept the 5/3. We changed this division into multiplication, and we flipped 2 9s over to 9 over 2. Now, if we do the math, we would get 45 over 6. And if we divide both sides by 3 over 3, we would get 2 over 15, and that would be it. If we wanted a mixed number, we would divide this. That would be 7, and remainder of 1, so that would be 1/2. So we get these two answers. Hopefully you enjoyed, and now you know how to use fractions in your everyday life. Make sure to subscribe and follow up on our other videos.